Namaskar, I am Dan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss the theorems on non-homogeneous equation of order n. So let us see our theorem. Let B be continuous on an interval I and let phi1 phi2 phi3 phi n be n linearly independent solutions of L of y is equal to y raised to n plus a1 y raised to n minus 1 plus a2 y raised to n minus 2 plus plus a n y is equal to 0 on I. Every solution psi of L of y is equal to b of x can be written as psi is equal to psi p plus c1 pi 1 plus c2 pi 2 plus c3 pi 3 plus plus cn pi m, where psi p is a particular solution of L of y is equal to b of x and c1 c2 cn are constant. Every such a psi is the solutions of L of y is equal to b of x. A particular solution psi p is given by psi p of x is equal to summation of phi k of x, k is equal to 1 to n, x naught to x, w k of t phi of b of t divided by w of phi 1 phi 2 phi n of t dt. Proof. The proof is similar to previous theorem. Let B be continuous function on an interval I. Consider the differential equations. L of y is equal to y raised to n plus a1 y raised to n minus 1 plus a2 y raised to n minus 2 plus plus a n y is equal to b of x, where a1, a2, a3 an are constants. If psi p is a particular solution of L of y is equal to b of x and psi is any other solutions of L of y is equal to b of x, then L of psi minus psi p is equal to L of psi minus L of psi p is equal to b of x minus b of x is equal to 0, and psi minus psi p is the solutions of corresponding homogeneous equation L of y is equal to 0, and it's called subtraction principle. Thus, any solution psi of L of y is equal to b of x can be written in the form psi is equal to psi p plus c1 phi 1 plus c2 phi 2 plus c3 phi 3 plus plus cn phi n, where psi p is a particular solution of L of y is equal to b of x. The functions phi 1 phi 2 phi m are n linearly independent solutions of L of y is equal to 0, determined in theorem, and c1 c2 cn are constant. To find a particular solution psi p, we use the variations of constants methods. Suppose psi p is equal to u1 of x phi 1 of x plus u2 of x phi 2 of x plus plus un of x phi n of x is the solutions of L of y is equal to b of x. Since psi p is the solutions, it satisfies the equations L of psi p is equal to b of x. Psi p is equal to u1 phi 1 plus u2 phi 2 plus u3 phi 3 plus plus un phi n is equal to summation of ui phi I is equal to 1 to n. Psi p dash is equal to u1 phi 1 dash plus u1 dash phi 1 plus u2 phi 2 dash plus u2 dash phi 2 plus plus un phi n dash plus un dash phi n is equal to u1 phi 1 dash plus u2 phi 2 dash plus u3 phi 3 dash plus dot 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 plus un phi n dash plus u1 dash phi 1 plus u2 dash phi 2 plus dot 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 plus un dash phi n is equal to summation of ui phi I dash I is equal to 1 to n plus summation of ui dash phi I is equal to 1 to n. Let summation of ui dash phi I is equal to 0. Then psi p dash is equal to summation of ui phi I dash. We have psi p double dash is equal to summation of ui phi I double dash plus summation of ui dash phi I dash. Suppose summation of ui dash phi I dash is equal to 0. Then psi p double dash is equal to summation of ui phi I double dash. Continuing the same assumption, we get summation of ui dash phi I dash is equal to 0. So psi p dash is equal to summation of ui phi dash phi 1 dash. That is ui dash phi dash is equal to 0. This implies that psi p double dash is equal to summation of ui phi double dash. Summation of ui dash phi double dash is equal to 0. This implies that psi p double dash triple dash is equal to summation of ui phi triple dash, and so on. If summation of ui dash phi raised to n minus 1 is equal to b of x, then psi p raised to n is equal to summation of ui phi raised to n plus b of x, and L of psi p becomes L of psi p is equal to summation of ui phi raised to n plus b of x plus ai summation of ui phi raised to n minus 1 plus a2 summation of ui phi raised to n minus 2 plus dot dot plus an summation of ui phi is equal to b of x plus summation of ui plus into phi raised to n plus ai a1 ai phi raised to n minus 1 plus dot dot plus an phi. Thus L of psi p is equal to b of x, and therefore psi p is the solutions of L of y is equal to b of x. Therefore the problem is now reduced to solving the system given below for the functions u1 u2 u3 dot 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 un. Summation of ui dash phi is equal to 0. Summation of ui dash phi dash is equal to 0. Summation of ui dash phi double dash is equal to 0 dot dot summation of ui dash phi raised to n minus 2 is equal to 0. Summation of ui dash phi raised to n minus 2 1 is equal to b of x. Thus we have system of equation pi 1 pi 2 dot dot pi n u1 pi 1 dash pi 2 dash dot dot pi n dash pi 1 double dash pi 2 double dash dot dot pi n double dash pi 1 raised to n minus 1 pi 2 raised to n minus 1 dot dot pi n raised to n minus 1 u1 dash u2 dash u3 dash 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 un dash is equal to 0 0 0 b of x. By solving above system of equation by Cramer's rule, we get uk dash of x is equal to wk of x into b of x divided by w of pi 1 pi 2 dot dot pi n of x. K is equal to 1 2 3 dot 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 n, where wk of x is the determinant obtained from w of pi 1 pi 2 dot dot pi n of x. By replacing the kth column pi k dash, pi k double dash 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 pi k raised to n minus 1 transpose by 0 0 0 0 1 transpose. If x naught is any point in I, we can integrate uk dash, and the functions uk can be written as uk of x is equal to integral from x naught to x wk of t b of t dt divided by w of phi 1 phi 2 dot phi n of t dt. K is equal to 1 2 3 dot n. The particular solution psi p now takes the form psi p of x equal to summation of pi k of x naught to x wk of t b of t dt divided by w of phi 1 phi 2 dot phi n of t. Now we are in positions to find out solutions of the non-homogeneous equations of order n. Observe that a particular solution psi p satisfies psi p of x naught is equal to psi p dash of x naught is equal to psi p double dash of x naught is equal to dot is equal to psi p raised to n minus 1 of x naught is equal to 0. Now see here example of non-homogeneous equation of order n. Put the solutions psi of y triple dash plus y double dash plus y dash plus y is equal to 1 will satisfy psi of 0 is equal to 0, psi dash of 0 is equal to 1, psi double dash of 0 is equal to 0. Answer: the characteristic polynomial of the corresponding homogeneous equation is p of r is equal to r cube plus r square plus r plus 1. The characteristic roots have I minus 1 minus I1. The basic solutions of the corresponding homogeneous equations are phi 1 of x is equal to cos x, phi 2 of x is equal to sin x, phi 3 of x is equal to e raised to minus x. To obtain the particular solutions of the form psi p is equal to u1 phi 1 plus u2 phi 2 plus u3 phi 3, we have to find w of phi 1 phi 2 phi 3 of x and wk of t for k is equal to 1 2 3 dot n. W of pi 1 pi 2 pi 3 of x is equal to cos x sin x e raised to minus x minus sin x cos x minus e raised to minus x minus cos x minus sin x e raised to minus x, and w of pi 1 pi 2 pi 3 of x is equal to e raised to minus a1 x minus x naught. W of pi 1 pi 2 pi 3 of x naught is equal to e raised to minus x w of pi 1 pi 2 pi 3 of 0. W of pi 1 pi 2 pi 3 of 0 is equal to 1 0 1 0 1 minus 1 minus 1 0 1 is equal to 2. Therefore, on scales of pi 1 pi 2 pi 3 of x is equal to 2 e raised to minus x. W1 of x, W2 of x, W1 of x is equal to minus e raised to minus x cos x plus sin x. W2 of x is equal to e raised to minus x cos x minus sin x, and W3 of x is equal to 1. U1 of x is equal to integral from x w1 of t b of t divided by w of pi 1 pi 2 pi 3 of t dt is equal to minus 1 by 2 sin x minus cos x, and u1 of x is equal to 1 by 2 cos of x minus sin x. Similarly, we can evaluate u2 of x, u3 of x, and psi p is given by u1 pi 1 of x, u2 pi 2 of x, u3 pi 3 of x, and it gives minus 1 by 2 cos x minus sin x cos x plus 1 by 2 cos x plus sin x sin x plus 1 by 2 e raised to x e raised to minus x is equal to 1. The most general solution is psi of x is equal to psi p plus c1 pi 1 plus c2 pi 2 plus c3 pi 3 is equal to 1 plus c1 cos x plus c2 cos x sin x plus c3 e raised to x. And putting and we evaluate c1 is equal to minus 1 by 2, c2 is equal to 1 by 2 and c3 is equal to minus 1 by 2. Therefore, the solutions of our problem is given by psi of x is equal to 1 plus 1 by 2 sin x minus cos x minus e raised to minus c. And this is our required solutions.